Without the sun, we wouldn't have life. Civilization in the future would never be the same. In order for us to understand what would happen if the sun didn't exist, we must first understand what the sun does for us right now. Here we have two protons from two hydrogen atoms. They are attracted by way of the strong force, which is a theoretical process that occurs inside a particle in which color exchanges between fractional electric charges, or quarks. After they collide, the byproduct is a positron and a neutrino, while the proton changes into a neutron by way of the weak force. A neutrino contains force carriers that are called W boson and Z boson. W boson can be positively or negatively charged, while Z boson has no charge. This is the flavor of a neutron and of a proton. The up arrow is a positive charged quark, while the down arrow is a negative charged quark. So here we have a W boson that came from a neutrino, and it's negative. The negative W boson will change the positive up quark inside of the proton into a negative one, thus changing the flavor into a neutron. Since neutrons have more mass than protons, this hydrogen 2 is not a normal isotope. In fact, it's actually known as deuterium. In the third stage of this process, hydrogen deuterium will collide with one single proton. The byproduct is radiation through the form of gamma rays. Photons are small particles that carry light. When they leave the sun and travel onto Earth, they beam in the shape of gamma radiation, which are high-frequency waves. Collision will turn into a helium-3 isotope, which will collide with another helium-3 isotope and create the final product that is helium-4. The remaining two protons will be released. Well, in order to figure that out, we must first understand what's inside the air we breathe in. Let's take a look at air composition. Air is roughly composed of 78% nitrogen, 20% oxygen, 1% water vapor, and 1% all the other gases. Cold air particles are just particles that don't receive enough of the sun's light to provide them with energy. That's why they are more constricted and compact, and why they don't move about. Warm air, on the other hand, is very different, because when air particles do receive the sun's light, they also receive the sun's energy. This energy is what makes the air particles move about in a big frenzy. That's why warm air is less dense than cold. Meanwhile, cold air has nowhere else to go but the bottom, so that's why it sinks. Warm air has an area of low pressure, while cold air has an area of high pressure. The movement between the air moving from high to low is what creates wind. And that's how the sun inherently creates wind.